Okay, and a good morning to everyone. And I'm eating some beef jerky that is really hot. Yes, eyes watering and all. That was Neil Diamond, and what was the cut on that? Sweet Caroline. Sweet graphing. We have some problems we've been doing with graphs. So let's find out how you're doing. Take out a piece of paper. So just take out a piece of paper and a straight edge. Got a credit card, edge of your book. Okay, whatever, ID card. Okay, piece of paper, straight edge. That'll do. B of A is about as good as anything at this point, even if they are charging an ungodly rate of interest. Okay, now, what I want you to do is draw me a coordinate system and label it, filling up the page in the best style that Kim would do. So a full page coordinate system. Yeah. Will you pass some rulers back to those poor people back there who don't have a straight edge that's long enough? Okay. And Robert? Label it, X and Y. Passing straight edges around. Okay, coordinate system, label it quickly. Now this is bringing up a comment that Michael and I talked about. How long does it take you to draw a coordinate system with reasonable markings? You can go 2, 4, 6, 8 on all 4 quadrants. So you want 4 different scalings, vertical, positives and negatives, horizontal, positive and negatives. Have your name on the paper, at the top of the paper. Okay, go ahead and label it quickly. This shouldn't take you too much more time for that. Then I'm going to write an equation on the board, and I want you to graph the equation. Okay. So as soon as you get the markings done, we'll give you another 20 seconds. Okay, the idea is that you can do a coordinate system very quickly. Okay. And now, I'm going to write an equation on the board, and I want you to graph it. But there are 2 things I want you to do. I'm going to write the equation one way, and I want you to write it in slope-intercept form, solving for y by itself first. Then you get a choice of graphing it in one of 2 ways, either as 2-intercept or as slope-intercept, to get full credit for this problem. To get partial credit, just plot 3 points, your choice. This is a 5-point problem, extra credit, you'll be turning it in momentarily. This is in celebration of you being here. Okay? And this will be added on to your 200-point final as a supplementary. So here's your equation. Let's say that you have 3x minus 4y, and that's equal to 12. Okay? That's the equation. I want you to graph it. But first you have to solve for y, and you get a choice of 3 ways of graphing it. Maximum credit, either 2-intercept or slope-intercept form for graphing it, and partial credit, not the full 5 points, partial credit just finding 3 points that work. But if you do 2-intercept, just 2 intercepts does it. Graph the line. Okay, we'll give you a few moments to do that, to graph the line. The 2-intercept means where does it cross the x-axis, where does it cross the y-axis. That's what a 2-intercept is for translation. Okay, we'll give you a few moments to do that. And for those of you who are watching, you might want to try that also. Just whip out a piece of paper. Use a straight edge, anything that gives you a nice solid line. Draw a horizontal, vertical axis. And there are 3 ways that you could do this. Choose the way you want to do. I want you to graph the line. Now, I'm going to take some time to draw a coordinate system on the board. That's what I ask everybody to do to get started. So I'll go to the board and start my coordinate system. My straight edge happens to be a meter stick. So I'm going to run a vertical axis and a horizontal axis. This is typically called X, and this is Y. The origin is here, and then I'm going to make some uniform measurements. Now, this is a little bit hard for you to do in paper. It works really great on a blackboard. Trying to get those uniform. Okay, so I have a coordinate system. All 4 quadrants represented. Okay, and your idea is to graph me this line. And I'm going to ask you to turn this in momentarily. Okay, so we'll give you a chance here to do this. I've asked you to solve for y by itself. That's 1 point. Just getting y by itself. And then I want you to get 2 points that you can join together to draw me the line. You have 3 methods you can use. You only need to use one of them. So waiting for you to finish that. This would be a typical kind of question on a final. Okay, let's slide over to the equation again, Ernie. So you have 3x minus 4y equals 12. And all you have to do is find where the line will cross the x and the y axis and join them. Do we have anybody who has a solution for me that they want to submit for extra credit? Anybody? Well, y by itself will give you 1 point. No, don't tell me. You submit it. That means you turn it in. And if you have the line graphed, that gives you additional points. So I'm just trying to wait you out here to see if you can get me a graph, because I'm going to collect the paper to get your 4 points before I talk about the solution. Okay. I'm going to wait about another minute, and then we're moving on. So I apologize for the delay here in terms of the presentation, but it's something that I wanted to give this group an opportunity to do. So you're getting 2 points, plot the 2 points, join the line, the points to get the line. Question, Sandra? You can do 3. Do 100. But 2 is all I need. Okay, we're down to about 30 seconds. Now, if this was a soccer practice I was running, that 30 seconds could morph into at least 2 minutes. Just keep saying, only 20 more seconds, another minute, another 10 seconds. Okay. Just pass it over this way. Pass it to Michael, and Michael will hand it to Raylene, and Raylene will pass it to me. So whatever you've got, let's see. And I'll return the papers to you at the end. And we're going to do that problem on the board. That was given with reluctance, I can see. And just over to Raylene, if you would. Now, give Michael 15 more seconds to join his points if he's going to do that. You want to join him? Okay, hand it over. So what are you going to do if you get y by itself? Well, you go ahead and say negative 4y is equal to 12 minus 3x. I just subtracted 3x from both sides. And I want y by itself, so I'll divide both sides by negative 4. So that gives me y on the left, a negative 3 here, and a positive 3/4 x. Now we usually write that in this way, 3 over 4 times x minus 3. That's slope-intercept. How many got that? Ay caramba. Okay, that is a process that you really you have to be able to do after this semester. Take an equation in two variables and write it y or x on its one side only. Kim? I just want one by itself. So if you don't want this one here, how do you get rid of a term? Subtract both sides. Doesn't matter. I'm going to subtract the same thing from both sides. When I do that, I get negative 4y on the left, and I get 12 minus 3x on the right. That's correct. Sandra? When I divide the left side by negative 4, I divide the right side by negative 4. Remember, I've done a very fundamental operation here. And we state it in a general form. If A is equal to B, there are two things you can say about equality. If A is equal to B, you can subtract or add the same things to both sides. So what we usually say is A plus C equals B plus C. Now it so happens C can be a negative number, and that's what I used. If A is equal to B, I can divide both sides by C, and it's still going to give me something equal. We've been doing problems like this with one variable with no trouble. Now I'm asking you, I'll be with you in a minute, Robert, but I'm asking you to extend it. If you want y by itself, you don't want 3x on the left side. So how do you get rid of that term? Subtract that term from both sides. So I added negative 3x to both sides. 12 plus negative 3x is 12 minus 3x. Robert? I haven't gotten to there yet. Have not managed to talk. Gotten to. Good English. I have not managed to yet plot points. In terms of what I'm doing, I'm simply trying to get y by itself because this is called the slope-intercept method. That gives me another way of graphing. So now let's plot the points. Before I go on, Michael.
12 minus 3x divided by 4.
By negative 4, you divide into each part. Okay, let's look at this part here. I have 12 minus 3x over negative 4. That is the same as 12 over negative 4. And I'll add to that negative 3x over negative 4. We've usually worked backwards combining fractions. This is breaking it apart. That was that intermediate step that I asked problem after problem after problem in Math 10. This equates to this. I'm just working backwards. So negative 4 goes into 12 and gives you negative 3. This just becomes 3/4 x. So this is y at this point, and all I did was say I'll put the 3/4 x first. So this became y equals 3 over 4 times x minus 3. And what's the nice part about that form? What does it tell you? No. I ask you simply to memorize this the last 2 days. It's this form. This is called the y-intercept. So that told you that the line crossed here at -3. 1 point, bingo. This is what we've done yesterday. This was called the slope. Rise over run. And this is what I did yesterday for the first half hour. Rise over run. So this says your run is 4 and your rise is 3. So I start here at this point. Hope that's going over parallel. And okay, there's a run of 4, a rise of 3, second point. Line. Done. Two-intercept method. We spent time on that in the last 2 days. How do you find your two intercepts? You get two ordered pairs. In one of the ordered pairs, you let x equal 0, and the other ordered pair, you let y equal 0. And I rigged the problem like crazy. Let's slide over to the left here. Here was my equation, right? 3x minus 4y equals 12. Now, I'm going to go to the ordered pair where I had 0 for y. So if 0 is y, that part goes out, correct? So if y is equal to 0, 4 times 0 is 0. Now, if 3x equals 12, what does x have to be? 4. That's one of my intercepts. The other intercept was when x is 0. Okay, back to here. Let x equal 0. So 3 times 0 is 0. Negative 4y equals 12. What must y equal? Negative 3. Okay. 0, negative 3. There it is. 4, 0. There it is. Join the 2 points, and you have your line. If you got that, then you had a correct solution. How many had the graph? One of you? Marisol, you didn't get that then? You acted like you got that. The graph. I just asked. If you got the graph, raise your hand. Aye. So I have 2 of you who got it. Okay. Did you use the two-intercept form, Marisol? That's called the two-intercept. Okay, what method did you use, Robert? Two-intercept. Okay, Sandra, you were talking about 3 points. What method were you using?
The only part that I didn't do is divide both sides by 4. I was doing it that way, but I didn't get to do that.
Ah.
So I was following.
So you ended up with a different slope, and that would give you a different line.
Right. I was doing that one.
You had a negative slope.
Yeah.
Okay, so I assume you had negative 3 over 4.
No, I didn't have any over 4. I had negative 3 minus negative 3.
Okay, so you canceled here and said that's gone, and then I just have negative 3x.
Yeah.
Ah. Okay, you've got to remember that you divide into both parts when you cancel. Okay. Any question that you can ask there? Okay, let's say you didn't like two-intercept method, and you didn't like the slope-intercept method, and you wanted to choose points. Let's see if we can choose points well. So I'm going to make a t-table. Now I'll just write the equation so we don't have to keep going back and forth. 3x minus 4y is equal to 12. So I have to find x's and y's that are whole numbers, or at least integers, could be negative values, but I want to avoid fractions. So what could I put up there that would give me a 12 when I'm doing this? And I'll give you one way I would think of it. if I could get 36 minus 24, that would be 12. How could I get a 36 minus a 24?
So X could be 4 and the Y could be 6.
You get a negative 12. Be careful. If X is 12 and Y is 6. No, the 3X is not 12. X is 12. So 3 times 12 is 36. 4 times 6 is 24. 36 minus 24 is 12. Okay, if I take X at 8, that would give me 24. If I do Y at negative 9, that would be 24 and 36. 24 and 36 doesn't come out 12, but you're thinking right. You just have a sign you need to take care of. If I run this at negative 9, then this at what? Negative 9 for Y gives me a positive 36. I want this to be a negative 24. How about negative 8? Anything else? Let's get a third one. Please silence. Okay. Is there another one I can get? Yeah, you can pick any number. I just want them to be integers. I don't want them to be fractions, and they have to satisfy this. So I could say X is 5. That would give me 15. But minus 1 times 4 would give me an 11, not 12. I have to have 12 on the right side. So I'm still waiting you to pick me one more ordered pair. X at 6 would give me 18. You're close. If X is what now? If X is what? 6. Okay, so that's 18, correct? And if Y is 1, that would give me 14. No cigar. 8 and 3. Okay, if X is 8, that's 24. And minus 12. So I want 8, 3. Okay, now notice something. Rise and run. If you add 4 to 8, you get 12. Add 3 to 3, you get 6. Can you give me another one doing the same thing? No, I want a 12 at the end. I did the run, added 8 to 4, and got 12. 3 and 3 was 6. So if I added 4 to 12, I would get 16. Add 3 to 6, I get 9. Will that work? Three times 16. 3 times 16. 3 times 16. Waiting for a number. 48. Very good. And 4 times 9. 36. 48 minus 36. Sure enough, works. Okay. Let's go to here. You had a negative 8. Add 4. Negative 4. Add 3. Negative 6. Does it work? Yeah, 20 and 12 will do it, but does this one work? Check. If X is negative 4, this becomes negative 12 plus 24. It works. Now, if you know the slope and you can find one of these, you can find a whole bushel bucket full. Bushel basket. Now, what Michael observed is if I added 4 to 16, I'd be at 20. And add 3 to there, 20, 12 will do it. 24, 50. You just go on forever. Does that help? It works for any equation when you have a slope that's a fraction. Yes, once you find one point, you can find infinitely many. You're just stair-stepping your way, one step at a time. The slope was 3 over 4. Now, what does that 3 over 4 tell you? If you go 4 units to the right on x, you'll go up 3 units in y. So if I start a point like this, then it says if I go over 4 and up 3, I'll get another point. And if I go over 4 and up 3, I'll get another point. And if I go over 4 and up 3, etc., stair-stepping your way. If I had 7 over 8 for my slope, I would go over 8 and up 7, over 8 and up 7, over 8 and up 7, just walking up the stairs to the sky. Michael?
Is it easier doing this on the slope, or is it easier?
The question I'm being asked, is it easier to find the slope or easier to finish the comparison? To intercept?
Yeah.
Okay, interesting question. Easier to find the slope or the to intercept? Remember I said I rigged the problem? This was the original equation. Now, if I don't rig it, and let's say I have a 7 here, when you let x be 0 or you let y equal 0 and you try to find the value of the other variable, it's not going to go into 7 nicely. You're going to have some fraction, and I try to avoid that. So I don't use the to-intercept method unless I can get integers. So if I've been kind to you, where this number is a multiple of 3 and 4, so I could add a 12, I could add a 24, a 36, a minus 12, a minus 24, it would have worked nicely. But I pick something that's not a multiple of 3 and 4, like a 7 or a 9 or a 15 or 11. It doesn't work well. So then what do I do typically? Well, I try to go ahead and write it in slope-intercept form. Now, if I don't get a nice integer here, then this isn't helping me a whole lot, because my intercept's going to be some fractional part. So then, if the slope-intercept doesn't work nicely, then I'm back to my t-table. And I'm hunting for something that I can find, one number that'll work. So let's say, just for the heck of it, that I had given you 3x minus 4y is equal to that 7. Now, this is where mental arithmetic really is demanding. Is there something I can use for x and y that's going to give me a 7? So, for example, if x is 3, that's 9. And if y is 1/2, it would work. Again, if x is 3 and y is 1/2, that gives me a 7. Or hold on, I want not that, I want what, negative a half? No, I'm right. 3 times 3 is 9, minus 2, and that would be 7. Now, I don't like this because it's what? A half. So, the question, can I find something else that's going to work? And by the way, if I go ahead and I solve for y, I'm going to have the 3/4 again. The slope will be 3 over 4. So that means if I go over here 4, I go up here 3, I'll still be at a half. I go over another 4, up another, I'll still be half. You are not going to find on this line, it appears, a point which is going to be an integer for both x and y. That's probably the closest I can do. So finding a single point sometimes is tough. Now, on the test, again, I'm not trying to put your back up against the wall. If I do a 5 and a 2, does that work? Ernie may be right. I didn't see it. If x is 5, 15, and 2, he's got it. I didn't see it. 5 and 2. 15 minus 8. Now what can you do? If the slope is 3/4, that means a 9 and a 5. If the slope is 3/4, add 4 here, add 3 here. So that would say 9 and 5. Does that work? 27 minus 20. It works. Now, all I saw was the 3 in this. I didn't happen to pick up on the 5, too. And you're there, and it goes. Okay, 13 and 8. Yes, 13 and 8. That would be 39 minus 32. Gives you a 7. So if you can find one of those ordered pairs, then you can find a whole bunch of them. Any further discussion there? 3 techniques. Kim? Okay, I had a run of 3/4. Does my first number not work? That's what I want to know at this point. Yeah, it works. It's just it didn't happen to give me. Otherwise, if I add 4 to this, I'll get 7 and 3.5, which happens to be a point. But if I'm looking for integers, and if I can find the first one with an integer for both parts, then I add 4, and I'm in business. Let's go the other way. Subtract 4. You'd be at 1, and subtract 3. Negative 1. Does that work? 3 times 1 is 3, plus 4 is 7. That's one I should have seen at the beginning, and I feel embarrassed by that because 3 and 4 is 7. That would have been a no-brainer, and I did not see that one. Okay? And I'm embarrassed that I didn't. Because I didn't have multiples, but 3 and 4 is 7. All I had to do was get 3 plus 4, and that, as you can see now, is like, oh yeah. That's after the test is done. You've walked out the door, and you didn't see anything, and you say, oh, for crying out loud. And you know you could have had 5 more points in the test. Now, what I'm concerned about, 2 days of graphing. We couldn't get all of you plotting the points and getting the line drawn. Marisol, you have a question. I have several too, but go ahead.
On the test, are we going to specify
Okay, the question that's being asked, on the test, am I going to specify what method you must use? Maybe. I haven't written it yet, so I don't know what I will do until I do it. Pardon? Doing the mental arithmetic to plug into that is not something everybody feels comfortable in doing. I concur. So maybe I should say using one of 2 techniques. Okay? But at the same time, let's rephrase this in a different way. Can you graph a line using something? I mean, one thing to say use a particular technique, but if I say, hey, it is open to you except for consultancy. You can't ask Ernie for help. Okay? And get your ordered pairs that way. So if you were just given a problem and given any technique, can you do it? What I'm finding that I didn't have 100% on that when we started with the idea, here's a problem, graph me the line. And yet you've been graphing lines for 2 nights, supposedly. Not necessarily well, but you're supposed to have been graphing lines for 2 nights. Okay, and if you were coming into a Math 70 for me, after knowing what I know about the Math 20 and what you should be doing at the end, my expectation would be that if I give you an equation such as 3x minus 4y equals 12, and I say, will you please graph this? You have any technique you want. You can use ordered pairs, you can use 2 intercepts, you can use slope intercept. I would expect you to be able to do it. That's part of your background at this point. Now, I know we're at the end of the semester, and it's always dicey to cover new material at the end of the semester and hope that it's going to be there, because you can afford to do what? You can afford to dismiss it and probably not suffer greatly. You can get through the course, you can do well in a final, and not know the material. That's a dangerous part for me, to be doing this at the end. But of all the things we are doing, what is the most critical skill that you could learn from what we've done in Math 10 and Math 20 regarding your future in any math course you take after this one? And the answer to that is graphing. That you must be able to graph points, and you must be able to graph a line. Okay? Because we are going to, as I showed you yesterday, do 2 lines at the same time and find where they meet. We are going to take a line, and instead of having equal, we're going to put a less than and get half of the rectangular coordinate system plane, as we call it, the Cartesian plane. So if I think of this line, as we slide over now, Ernie, to here, and if I wanted to know all the points that would make this statement about 3x, otherwise I'm going to look at this now, 3x minus 4, helps if I don't try to say 4 and y at the same time, less than or equal to 12. I graph the line the same way I've done it, and then I take a test point, and I ask, is the origin going to make that a true statement? Is 0 minus 0 less than 12? Do we agree with that? That 0 is less than 12. To the left of 12. Marisol? Thank you. You were just staring at the board. Okay, so what region do? I just means everything above the line is my solution. But again, you have to be able to graph the line. That would be 70 right there. And I'm pushing you in 20 just a little bit. Okay? The technique used in the book has been pretty much intercepts or plotting points. But what I'm trying to avoid is fractions when I look at the ordered pairs. Okay? Now what I'm going to do is come back center, Ernie. My hope today went down the drain about 20 minutes ago. My hope for the day was that I could give you that one problem. Everybody would plot that one way or the other. We would all have a nice line, and then I could say, all right, now we can review. Not the case at all. So, in terms of graphing, the technique that's being used, and I guess this is the part that I'm a little bit concerned about when you substitute x and get y. Now that's the technique that's being talked about here in this third objective, and it's the important one to me. It says graph a line. See if I can get that any lighter. That's about the best I can do there. It says graph a linear equation in x and y. Okay, we've done that, but note that as we look at these ordered pairs that have been given to us, these are called the solutions for that equation. So I'll see if I can get the equation x plus y equals 5. Now that's making it pretty easy, right? You can eyeball that and say 1 and 4, 2 and 3, 3 and 2, 4 and 1. Much easier. But the question, how do you get those ordered pairs? And the argument here is you let x be some value and solve y. I'm on page 672 at the top of the page. 672. So the question is, how do you get these pairs? And that's what I'm trying to get you to the point of doing in terms of graphing. So that's an easy one. Just give me a pair of integers that have a total of 5. 0, 5, 1, 4, 2, 3, 3, 2. You can go for quite a ways, unless you want to get into negatives. Okay, let's come off there. And then we come to a little harder problem. But again, this is sort of an easy one, correct? Because 2x plus y is supposed to be 5. So if you put in an x at 2, that gives you 4, and 4 and 1 is 5. Again, you can see those rather easily. As I go to the side now, let's leave that on the document cam for a moment. I'm trying to take you one step further. Okay? And again, if I look at 2x plus y equals 5, I'm trying to take you a little bit further and say, yeah, you can let x be anything you want there. That's true. So I might let x be 5. So if x is 5, I have 2 times 5 plus y must equal 5. And I can do what? Solve for y. So you substitute and then solve for y. So you subtract 10 from both sides. And I hope you see that y equals negative 5. So we say we have the ordered pair 5. Negative 5 should make that a true statement. That's an ordered pair. But watch what happens when I mix it up just a step more. Now, remembering what I didn't recognize, the 1 and 1 works because 3 and 2 is 5. Okay, so I can pick up that 2 times 1 plus 3 times 1 is equal to 5, so 5 equals 5, so my pair is 1, 1. Now finding the other ones may not be as nice, so how would you do this maybe to find the other ones quickly? Remember what we did with slope. What am I going to do to get the slope? One more time. I want y by itself. Subtract 2x from both sides. Sandra? I'm going to subtract 2x from the left, and I have 3y left. Do you agree? I'm going to subtract 2x from the right side, and I get 5 minus 2x, which I would prefer to write as minus 2x plus 5. Now I'm going to divide by what? The 3. I want y by itself. So I learned a lesson. I'll do that. And this maybe avoids the error. So y is what? Negative 2 over 3 times x plus what? 5/3. Do we agree? Okay. That, by the way, is the y-intercept, which I'm not real in love with. It's a fraction. Don't like that. But the slope is what? Negative 2 over 3. So if I change the x by 3, meaning I'm going to go to the next point, and that's at 4, what happens to the y? It has a rise at negative 2. So what's 1 plus negative 2? Negative 1. Does it work? You understand what I mean by does it work? What do you do to show that it works? plug 4, negative 1 into this equation, correct? So 4, 2 times 4, plus 3 times negative 1, and I want to know, does that equal 5? Is 8 minus 3 5? Yes. And 5 equals 5, so we have a solution. Okay, give me another ordered pair. I want the next one. The immediate next one applying the slope. Okay, 7, negative 3. How did you do it? You added the run, which was 3, to my x value to get to 7, and the rise was to drop then another 2 off negative 1, which goes to negative 3. Does it work? Substitute to find out. Is 2 times 7 plus 3 times negative 3 going to equal 5? If I've done what I should be okay. 2 times 7 is 14 minus 9. Is that equal to 5? It is. So what would the next one be? 10 negative 5. All that Marisol is doing is saying the slope is negative 2/3. Remember, the slope is negative 2 over 3. The 3 is a run, and this is a rise. So you run over to the right side. So I go from 4 to 7. I ran 3 units. And then I'm either going to go up or down depending on the rise. And it says go down another 2. So I'm going to have a 10 would be my next, negative 5. Okay, and so on. 5. The 5 over 3 over here, I simply ignored because I was not trying to do it as slope-intercept. If I wanted to do it as slope-intercept, I go down. See, I start with my coordinate system. So if I wanted to use that, now this is using the slope-intercept. Well, just a minute. Let me try to answer the question here. Here's the x. Here's the y. I'm going to do this 1, 2, 3. Make sure I keep my hand the same spacing. 2, 3, 1, 2, 1, 2. Don't you wish you had a blackboard in your desk and you just do that instead of having it? It'd be so nice. Okay. Now, where is 1 2/3? About there. Okay, that's about all you can do and say it's about there. 2/3, about 2/3 of a cup. That's my intercept. Now, what does it tell me? If I go over from there 3 units, that's to this, I'm supposed to drop down what? 2. Okay, so here's my spread. So start there, 1, 2. So I've got to be down at this point, and unless I have a compass or something to help me, a pair of dividers, it's sort of dicey, but this is over 3, down 2, and that's my next point. And again, all I have to do, this is called the slope-intercept form, join those, put arrows at each end, and I have my line. And notice it is going downhill. The slope was negative. When the slope is negative, downhill. Okay, every time I cover a new wrinkle, I get a frown. Marisol, you're frowning. Sandra's frowning. Michael's frowning. Who wants to frown with a question? Michael. We're speechless. We got a question. It just won't come out. Okay. Oh, sliding back over. Now, let's come back here. The 1, 1 we picked because it was easy to get, right? And then we said the slope was negative 2 over 3. So let's run off of this 1, run with 1, run over 3, that gets me to 4. But my rise was -2. So if I start at 1 and go down 2, how about -1? Okay, just a minute. Marisol.
So what method is this? Is that the...
This is getting ordered pairs. And I'm trying to put a wrinkle on it to make it possible to get the ordered pairs. Once you get 1, using the slope gives you a nice way of getting other ordered pairs with integers. I don't want to plot fractions. This is the ordered pair technique. The ordered pair technique, find an x, get a y, but my wrinkle, avoid fractions. Michael. Boy, when we start out okay, that means,
We don't know, right, so we don't like the y-intercept. We don't like that number, right?
I didn't like a fraction for a y-intercept, but I showed you how we could as we slide over. You could do it.
But we know what the run is for the
Slope, right?
So if we don't like,
Get another point.
say, you just have that.
I went over 1, up 1, and there was a point on the line that worked. And then I said, okay, if I start with that point, let's go over what? 3 and down 2 and get another point. If you can't get the first order pair, you're in bad trouble. Now keep in mind, my intent is not to be malicious on this test. I tried to give you a very, very nice problem when I gave you 3x minus 4y equal 12. Because 3 and 4 both went into 12. I wanted something that really worked well. It wasn't successful, but I tried. So I'm not trying to get something that's going to make it super hard. If I give you, and let's just look at a typical problem. I give you 2x plus 3y equals 6. What should your first reaction be? Just look for a moment. You're not seeing what I want you to see. The 6 is a multiple of 2 and 3. 2 will go into 6, 3 will go into 6. Hey, if that works, I get intercepts at the drop of a hat. If you can interrupt. I put in x at 0, y has to be 2. Put y in at 0, x has to be 3. Took 10 seconds, plot the points in 30 seconds, join the line in 5 seconds, you're done with the problem in a minute. Robert.
I remember the x minus 4y. Didn't we go over that?
Yes. Yeah. Good memory. But 2x plus 3y is 6. Neat problem. 3x plus 5y equals 15. 3 will go into 15, 5 will go into 15. You just sit here and say 0 for x, find y. 0 for y, find x. 2 points, plot them. Okay, I'm pleased that you see that as a nice thing. Now, if I say 3x plus 5y equals 8, so let's say I gave you 3x plus 5y equals 8. What technique do you think you would use here? The 1 and 1 works because 3 plus 5 is 8. That's nice. And if I can get a nice one, why not go for the slope? So if I go to the slope, 5y equals 8 minus 3x. Okay, I'm going to say something here. I keep getting these frowns every time I do something like this. Let's see if I give you the non-mathematical way of doing this and see if it helps. I do this with fear and trembling because if you remember it this way forever, I will regret it. But survival mode at this point. You didn't want 3x there, so move it across and it'll become negative 3x. Okay? So if you move something from one side equal sign to the other, it changes its sign. Good. I regret that. Now, I want y by itself. So you're going to say 8 over 5 minus 3 over 5 times x. What's your slope?
8 over 5. No, 3 over 5.
Oh, wait, it'd be this over, no?
Negative 3 over 5. You have to have the sign with it. The coefficient of x is your slope. You've got to memorize that. mx plus b, the slope is the coefficient of x. Just walk around today. The coefficient of x is the slope. The coefficient of x is the slope. Now, can you find me another point in the time I'm running out of? Go over 5. That means you have a 6. But this is dropping down 3, negative 2. Bingo, draw the line, you're home. With that, I'm going to give up with the following statement. Tomorrow is Thursday, right? More on graphs. Friday, I'm making a 2-hour session. We'll do 1 hour on tape. We'll go 2 hours for a review for the final. With that, Ernie.